Jai Hind to all. I am here to continue with my topic of data analytics and machine learning, wherein we were discussing about various inputs that is required for analytics. So, one of the important inputs would be in form of images, another can be in form of voice or in form of signals. These are various inputs that can be taken up for analysis and data analytics, and all those data, that big data that we are talking about, variety, velocity and variety of data that we are talking about, has to be handled and can only be handled with machine learning algorithms. So, that is why machine learning algorithm is a part of your second unit, as well as some discussion is there in the first unit as well. Just to give you an idea how data analytics and machine learning is connected. So, if we are able to appreciate this point that we have to collect data from various sources, then we have to think about one source as an image as well. So, the deep learning algorithms play a very important role in identifying the images, and they have proved themselves a very efficient algorithms for identification of images. And the basic fundamental idea behind understanding of images is as discussed in this slide, that suppose we want to first identify whether this object is a cat or a dog. So, we start with an outer layer that identifies its basic features, basic point of differences that may differentiate cat and dog, and those features are being filtered at each and every layer, and finally we get an output layer. So, while we are moving from a lower layer to a higher layer or an input layer and then various intermediate layers to the output layer, there is feature extraction happening at each level, and then finally there is a classification, either it is going to be a cat or a dog. So, this classification process takes lot of feature extraction processes, and that happens in each and every layer in a deep learning network, deep learning algorithms. So, this is the main point of difference where deep learning or machine learning differs. In machine learning, this feature extraction that is being done over here layer wise by the algorithm itself will be done by human, will be done exclusively by the coders or by the designer, whoever is handling the data. So, that is the main point of difference between deep learning and machine learning. Good enough. After that, we can move towards ensemble learning, next category of learning as well. So, this is the whole picture of machine learning algorithms. That why I am discussing it over here, because these are the ones, these are the algorithms, these are the algorithms which are going to be behind those data analytics system. You have to analyze data sources of data can be many, and then there can be many algorithms, and the basic classes of algorithms that has been identified through machine learning are classical learning algorithms is one whole set of algorithm that is consisting of supervised and unsupervised learning. Supervised can further be into for clustering, supervised and unsupervised. In supervised, we go regression, classification, SVM, decision tree, logistic regression, linear regression, polynomial regression. These whole family of algorithm is there with the supervised learning techniques. Then in unsupervised learning techniques, we are moving towards clustering, patterns identification, dimensionality reduction. These are all unsupervised learning of methods. In this, K-means clustering and agglomerative clustering and all these pattern recognition is very much done by association rule application as well. A priori, FP growth, these are all pattern, these are all responsible for pattern recognition or for market basket analysis. This is a whole another lot of collection of unsupervised learning algorithms. Then we come towards another class of algorithm, that is reinforcement learning. Examples can be like deep Q network, Q learning, genetic algorithm. These are all class of reinforcement learning, wherein the algorithm is system is learning out of the reward, and the basic idea behind reinforcement learning is the system is learning out of the reward or punishment features that is available. There is no supervisor as in case of this one, supervised learning means there is a labeled data that is going to say whether the classification has been done correct or not. Unsupervised learning, this is done first the clustering is done, grouping is done, and then the labeling is done. So, for supervised learning, the input is the we have the input and we have the output, we know the output, and the new data that comes in has to be classified and checked against that output. But there is no such provision in unsupervised learning. In unsupervised learning, the outcome is the labeled data. We get an outcome as a labeled data. Here we get an input, we give in labeled data as an input, it is a part of the input. Here the outcome is of labeled data. So, we label the data as per their classification, as per the properties that they have been clustered together, and then they are labeled. Reinforcement learning is altogether different approach, wherein we teach the system learns neither by with the help of supervised method, rather it learns by reward and punishment methods. As the child learns, it takes certain action, and if it gets certain reward, then that is it learns that this is a good thing that has to be done. So, that is a positive aspect of it, and if it is punished or if there is some punishment associated with it, that ways child learns that this is a wrong thing to do. So, that is the way of learning, either through reward or punishment depending upon whatever action he does and whatever reward or punishment he gets. So, that is the one way of learning, that is a reinforcement learning, altogether different class of learning over there. Then we have altogether new class of learning, that is neural network deep learning based learning. These are various names associated or they are basically instance of these type of this type deep learning. These are CNN, convolutional neural network, usually used to handle images, but no doubt they can be handled, they can handle text as well. Then RNN, recurrent neural network, usually LSTM and GRU, these are all usually used in text analysis, but can be used for images as well. Similarly, generative adversarial network is whole new class of neural network is there. Then autoencoder, perceptrons, these are all variations of machine learning apart from I mean they are basically a deep learning kind of deep learning and neural network kind of networks. Then altogether different class of learning is ensemble learning, boosting, XGBoost, bagging, stacking, AdaBoost. These are those algorithms which are basically running on getting a collective knowledge, collective data, collective decision from various algorithms. Suppose we have a data set, then we are dividing that data set and giving it to different classifiers, and then the collective decision of the classifiers are either averaged or usually it is averaged together to get the result that this is the classification done right or wrong. So, it is more of, you can say it is more of a polling method of getting a of classifying the elements. So, that is whole lot of story behind machine learning algorithms and the various classes of machine learning algorithms. The same has been put over here. These are classical, reinforcement, ensemble, neural network. Ensemble can further, as I discussed just now, that we have a multiple data, we can have a original data set that can be distributed into various data set D1, D2, Dn, and then different classifiers are being used on each data set. Say classifier 1, classifier 2, C and N classifiers are used, and then their combined decision is being averaged out or being polled out to find the correct classification. So, what are the steps involved? Create multiple data set of the existing data, then build multiple classifiers, and then take the intelligence or the decisions of the various classifiers, combine them, poll them, or maybe you averaged out them and then you get the combined classifiers. So, this is something like you are distributing the problem among 10 people and then 10 people are giving the solutions, and then you are finding either the best solution out of it or you are averaging the solutions got from those people. So, this is ensemble learning, this is the whole setup behind. You have a set of data set, then set of machine learning algorithms or classifiers being used, and then the combined prediction is being done. So, Ensemble is the art of combining diverse set of learners, individual models together to improvise on the stability and predictive power of the model. No doubt, the individual classifiers are when they combined a crowd sourcing kind of, you can say crowdsourcing. Why? Because you are taking the intelligence of crowd and then getting the best result out of it. So, that is no doubt going to be a better result than an individual result. So, in the above example, it is a combined diverse set of learners together to improve on the stability and predictive power of the model. In the above example, we combine all the predictions together, will be termed as ensemble learning. Okay, here is an example that I want to show for an ensemble learning method. So, what is ensemble learning doing? Basically, what do we get from this diagram? That's since our data is like a big data, like this elephant over here. Elephant is such huge, so all its property cannot be identified, all its features cannot be identified by one person. So, we have applied different classifiers, right. So, this if we just through this diagram, if we can appreciate this point that this elephant is equivalent to our big data that we are having, and then these people who are trying to explain the data, explain the features of the data are individual classifiers, then the combined knowledge of all these classifiers will give us the correct picture of the data, right. So, this is what is happening over here. For this person who is able to see only this part of that big data that I have been able to relate, this part of that big data, he identifies this part as an elephant is like a big snake. This portion which is being seen, which is being handled by this person, can see that this is a tree stump. Then again, this is the person who is able to just see this part of the data or handle this part of the data, says that it is actually a little furry mouse according to his interpretation. So, what are you saying? It is like a shelf of a leather. This person is claiming because he is able to see only this part of the big data or elephant. So, he is able to just appreciate this part. Now, we combine the knowledge of all these people and we are able to identify, okay, these are the attributes and these are the classifiers who are giving us this information. So, this combined information can be used to understand that it is the big data, what is the shape of the big data or what is the shape of the elephant over here. So, this has been compared, big data is equivalent to your elephant, and these are various machine learning algorithms or maybe you can say various classifiers being used, and the combined intelligence of these classifiers is being used to identify or work on that big data. So, this diagram explains the ensemble learning concept. Main cause of difference in actual and predicted values is noise, variance and bias. Noise, variance and bias is a common problem in any machine learning algorithms, and if we talk technically, then ensemble learning is trying to reduce this by bagging and boosting. It decreases the variance and increases the robustness of the model. So, combination of the multiple classifiers decreases variance. So, what is the purpose of this variance, noise, variance and bias? So, ensemble helps to reduce these factors except noise, which is irreducible error over in this case. Using techniques like bagging and boosting helps to decrease the variance and increases the robustness of the model. Combination of multiple classifiers decreases variance, and that is why ensemble learning is a popular technique when you go beyond your classical algorithms, because it is able to reduce those issues of common issues of machine learning algorithms, that is noise, bias, noise, variance and bias. So, we will not discuss bagging and boosting too much in detail in this section, because it is basically getting into machine learning and that is not desirable over here in unit 1. We will get deep into machine learning in unit 2. So, as of now, let us move ahead with the topic data analytics and data scientists. Analysts and scientists, basically analysts are the traditional people, more of they are statisticians. They focus on reports, KPIs, trends. Their process is static and comparative. Their data analytics is pre-planned, added slowly transform upfront, carefully planned, single version of truth, schema on data, load, retrospective, descriptive, AI. BI is business analysis, business intelligence is descriptive. Whereas when we talk about data scientists, although this data scientist has appeared from data analysts only, because data analyst is more of the person who is good at analysis, analytics, statistics. But data scientist is an very much advanced version of data analyst who is able to do prediction, prescription, preventive algorithms he can handle. Then he can identify pattern, correlation and models, he can handle various models, exploratory and experimental, on the fly as needed. What is the data source? They can handle the data scientists can handle the data as per the on the fly means online as per the requirement. Then transform in database on demand and enrichment, good enough. Probability, schema on query, and predictive, prescriptive, preventive. These are various advancement of a data scientist over analysts. So that is why we are looking for a data scientist in our industry, and not so much of importance is given to analysts. I have mentioned this. Big Data MBA course curriculum consists of this, and you will see that this is for more of MBA oriented people, and this is more of technical oriented people. Then we have next term. Various views of data, we have talked about it, various velocity, variety and volume of data. This we have already done in our and we need to connect it over here as well. So I'll just go through flip to through these slides fast, because this is why all tantrum is there regarding various types of machine learning algorithms. So, and next we are trying to see the evolution of big data and the big data analytics. We started from OLTP, online transaction processing system, then OLAP, and then real time. This is online and then real time analytical processing system. Real time analytical processing system, you are handling your streaming data, you are handling your live data. So this was the scenario in 1968-70, and now we are moving towards the 2000-2010, wherein we are talking about real time analytical processing system to improve our business response. So online transaction processing, online transaction processing, that was more about online transaction processing was more about our traditional DBMS. Then online analytical processing, an extension of DBMS, kind of extension of DBMS, but very much beyond, and data warehousing. That was the scenario. Now we are moving towards real time analytical processing system, and that is why big data architecture and technology is required. So we need to appreciate this evolution, so that we are able to see how the technology has transformed from mere handling structured data in a schema based DBMS to a storage of data, no doubt, but may not be very much schema based. Then we have real time analytical processing system, that is big data architecture and technology, that is altogether no SQL, that is no schema based at all. So this evolution needs to be appreciated. Why? Because we are moving from structured to unstructured and semi structured data, right? Next we are moving towards how Hadoop ecosystem is playing its role in understanding and handling this big data. As we have to handle streaming data, we have to handle huge amount of data. Then we have to make sure that we have whole ecosystem that is supporting it, and the whole ecosystem behind it is, these are various layers that we have in Hadoop ecosystem. It's a Apache product that talks about giving a whole ecosystem to support big data analytics. And that what are these components? What are its main components are HDFS and HBase, that is stored, that is required at the data storage level. Then we have data processing level, whereas first we store data, good enough. For that we have various distributed file system is there. Then we have data processing system, that is MapReduce and Yarn hold together different approach to process that data. Then we have data accessing system that is going to support our these huge clustered big data, and then we have data access good enough, and then data management. So, we need to appreciate that not one component can support this huge amount of data storage and processing. So, whole layer is at our plethora of these layers are there to support that. And the first layer is data storage, and that has data storage, data processing, data access and data management. At data storage level, we have HDFS, Hadoop Distributed File System. No doubt file system was there earlier also, distributed file system was there earlier also, but this is Hadoop distributed file system has certain more advancement over distributed file system in terms of having the minimum block size as 128, as opposite to this block size. They have increased on the, they have worked on the collective block size in HDFS, and HBase makes it a NoSQL database. So, makes it easier to handle to store this non-schema based data. Then we have data processing. For data processing, we have MapReduce and Yarn. These are all data processing approach wherein we have distributed system, parallel processing happening. So, we have data being sent on different nodes, processed at that local nodes, and then collective data is being the data is being collected. The MapReduce is an efficient and most important processing model that we will appreciate in upcoming lectures. Then we have Yarn, yet another resource negotiator. Why? Because clustering and resource management is very much desired when we talk about big data. So, MapReduce gives a more static structure of distribution and parallel processing. Yarn gives a more dynamic resource allocation. So, this is basically we can say Yarn, yet another resource negotiator. Yarn is an advancement over MapReduce in terms of how efficiently it is allocating its resources. So, it is using its resource, deallocating in it and reallocating it as per the requirement. So, this dynamic reallocation, that is the point of difference between MapReduce and Yarn, that makes it more efficient as a resource manager, right. Then we have data accessing. Data accessing can be done through Hive. It has been done Hive SQL, our traditional methods. Then we have Pig, then we have Pig for data flow, then we have Mahout for machine learning algorithms supporting. These are all modules available in Hadoop ecosystem. Mahout is for machine learning algorithms, then Avro for RPC and serializations. Then we have Scoop, the RDBMS connector. This is the RDBMS connector that is bringing our data into our for data into a database system. So, this is the data access module of it, and then we have data manager. Data manager is Ooze, the workflow monitoring, Chukwa, Flume, Zookeeper. These are various data management modules available in Hadoop ecosystem. So, basically if we dive into what it is Hadoop, Hadoop is an open source software framework for storing and processing big data. Nowadays, we are all working on open source software, and that is why big data or Hadoop ecosystem is famous. Why big data and Hadoop ecosystem is so much in market or so much desirable? Because of the availability of the softwares which are open sources. Of course, they are able to handle and process large data because of being distributed and parallel processing capabilities. Then, because of the clusters of commodity hardware. Then what is commodity hardware? Because since it is it is being handled by commodity hardware and not by traditional high-end servers. In fact, we are using commodity hardware. We will discuss what is commodity hardware. These are basically cheap, easily integratable hardwares which are of a plug and play type and easily replaceable. cost wise also, and integration wise also. So, these are commodity hardwares that are out of which these clusters are made. So, essentially it accomplishes two tasks: massive data storage and faster processing. Massive data storage because of various distributed parallel processing capabilities and because of commodity hardware. And since we are having commodity hardware, we can have more of backup. We will need to have more of duplicacy of data. So, we are happy over here maintaining a duplicacy of data, because if you install Hadoop ecosystem or Hadoop in your system, then there will be default replica that will be made out of all data is 3, and you can change that to 4, 5 or 10. So, why this default replica of 3 is there? Because we are handling with commodity hardware and that may fail anytime, but we are happy to handle our data analytics or big data through these commodity hardware, because they are cheap enough. Second of all, there is a lot of backup over there. So, we need not worry about it. So, that makes it a very conducive to use it for handling big data. Essentially, it accomplishes two tasks: massive data storage and faster processing. A core Hadoop consists of HDFS and Hadoop implementation of MapReduce. So, if we talk about out of that ecosystem that we talked about, the most important component of Hadoop ecosystem is your HDFS, Hadoop distributed file system, and MapReduce that we have talked, because it is HDFS where data is being stored, and it is MapReduce where it is being processed, and these components have necessarily to be very efficient enough to handle the big data. So, the same explanation is over here. We have HDFS, then we have MapReduce, then we have various management and data management tool. Similar discussion. Of course, it is an Apache product, and what is Hadoop ecosystem made up of? HDFS, MapReduce, HivePay, Avro, and various other components are there. But by default, when we install Hadoop, then we have only MapReduce and HDFS with us. So, Hadoop is basically a components of Hadoop ecosystem. The more Hadoop common is having the two with that HDFS and MapReduce we have talked about, then Chukwa, HBase. These are other components that we can go in detail if we want, but we need not go as of now. So, component of Hadoop ecosystem basic. Now, we are trying to zero in on the only two aspect of Hadoop ecosystem, and that is HDFS, Hadoop distributed file system, and MapReduce. So, what do we want to do in this? Hadoop distributed file system, as we can see, we have various HDFS clusters, and these are made up of commodity hardware, good enough. Then we have a common server over here, and each cluster is having a number of servers. Then we have certain name node and data node. Data node is actually the physical place where the data is being stored, and name node is the one which is going to have the index of the data being stored. So, we have name node and data node. Name node having all the information where the data is being stored, and data node is the place where actually the data is being stored. So, this is one cluster, and this cluster is made up of number of servers, a data node, name node. Similarly, there can be another cluster having number of name node and data node. Similarly, there can be multiple clusters, all being controlled and being managed through HDFS. So, this is the whole structure, Hadoop distributed file system. So, this file system altogether is distributed among themselves. So, that is all for HDFS. We will continue with HDFS and MapReduce in our next lecture. Thank you.